This is a CTI MSB generic modular block test wall. We're using this wall to demonstrate the principle of internal stability. On this CTI MSB generic modular block wall, we used two types of facing blocks. We added a surcharge and we burned the connections between the blocks and the reinforcements. This is another demonstration wall. These blocks are made of recycled tires, and they're so light they float. We also cut the connections on this wall. This is our full-scale retaining wall test frame at the University of Colorado at Denver. Here we construct and test CTI MSB retaining walls. The current test includes a full-height concrete panel facade with shredded tires as backfill. This is our full-scale landslide simulator. Inside, we construct landslides and test various remedies. The current test is a new concept we call the CTI Deep Patch. It consists of a negatively battered fabric wall and tire shred backfill. This is our direct shear device. It has 30-inch boxes, which allows us to test a variety of backfills, including shredded tires and sawdust. We can also test the interface between reinforcements and backfills. This is a part of the CTI test frame where we test the connection strength between the modular blocks and the geosynthetic reinforcement. What we have learned over the past several years is that CTI MSB technologies are the future in walls and steepened slopes. They represent the next generation in technology.
CTI generic MSB systems are simple to design and easy to construct. Let's look at a basic system. Backfill is a granular soil. Road base is a good choice. Everyone knows how to build with road base. The easiest facing for construction is a dry cast modular block. Geosynthetics can be used for reinforcement. Placement is as easy as it looks. Geosynthetic strength, spacing, and dimensions can be determined from the CTI design charts. Full-scale testing by CTI shows that this composite of backfill and reinforcement is 20 to more than 50 times stronger than the forces that drive internal failure. High-end geosynthetics have half-lives of several hundred years. Dry-cast concrete blocks can be designed to last at least 75 years. And road base is certainly a durable construction material. Safety, longevity, and simplicity are the hallmarks of the basic CTI MSB generic modular block system. Costs for this basic system are quite reasonable. Modular blocks cost $2 to $3 per square face foot. Reinforcements usually cost $2 to $3 per square face foot of wall. Granular backfill is about $2 per square face foot. Labor varies with location, but $5 per square face foot is a fair average for construction costs. At $11 to $13 per square face foot, the CTI MSB generic wall is one of the least expensive systems in the country. The cutting edge of the sword of economy is honed with research findings from CTI and by in-house MSB experts at the beginning of project development. Let's look first at how research has improved the economy of the CTI MSB systems. One of the first discoveries was that internally stabilized features do not require embedment. They are quite content sitting on the ground. While some guidelines suggest embedment of internally supported features, this only increases size and cost. Even a 1-foot embedment adds 20% to the construction. 3 feet adds a whopping 42% to the construction. Where foundation conditions will not allow the wall to be placed on the existing ground, simply excavate the unsuitable soils and replace the excavation with a compacted granular soil. Then build the CTI MSB feature on the improved platform. For the most severe foundation conditions, the designer may consider adding light reinforcements in the improved foundation. But for heaven's sake, don't waste money on a wider or taller wall than is required. The economies in applications with CTI MSB systems are maximized with in-house subject matter experts who participate from project inception. Transportation professionals can identify with the iterative process of finding the best fit for a new or improved facility. In this simplified example, the project manager can move the platform to any of several locations. If a cut is to be considered, the project manager uses geotech subject matter experts to determine subsurface conditions and to provide the most cost-effective design. In the case of bedrock, steep cuts can be used. But if the hillside is subject to landsliding, disaster could occur. The project manager would not leave the responsibility for design of this all-cut cross-section to vendors and contractors after the project has been awarded. This is not always the case with an all-fill section. Most state DOTs do not have MSB design expertise, and they are likely to follow one of 2 courses of action. In the first case, they will design what they know, which is usually a concrete cantilever wall. And if the subsurface conditions are unfavorable, the traditional designer will underpin the traditional wall. These constructions are fiendishly expensive, often 3 or 4 times the cost of MSB solutions. What can be missed without in-house expertise is the least expensive option, a steepened slope. And if the foundation is weak, then MSB designers can use durable, lightweight fills such as shredded tires, shredded tires make a good backfill for walls and slopes. Sawdust can be used as backfill. Expanded polystyrene is an excellent construction material. These modern designs take advantage of the principle of internal stability. No facing is needed except to prevent erosion. Several systems are available to reinforce the backfill and prevent erosion. This steepened slope demonstration project is a joint venture of CTI and Tensar Earth Technologies. The principle of internal stability can be illustrated by comparing a soil anchor with a segment of reinforced earth. If the nut of the soil anchor fails, the system fails. Whereas the most important role of the facing block on the internally supported system is preventing erosion. Reinforced steepened slopes and walls differ only in the angle of the face. Once the angle of repose of the backfill material is exceeded, the reinforcements take most of the horizontal load. The other choice a DOT may make is to simply draw a vertical line and leave the solution to contractors and vendors. This avoidance of responsibility denies the project manager the assistance of subject matter experts in wall selection during project development. An approved list is no substitute for internal expertise. Put the DOT people to work. Let them assume an ownership role and advance the MSB technologies. Our DOTs have capable engineers who would rather be self-reliant.